Our target 5.4 Mastery Learning Objective. I can use measures of central tendency and measures of variation to compare data. Vocabulary. Right, so we need to know what our measures of central tendency are and our measures of variation. So these are measures of central tendency, or the center of your data, the middle of your data. And our standard deviation is a measure of variation. So, the mean. You might have heard of mean before. Mean is another word for average. Okay? So if you had 10 numbers, right, you add them all up and divide by 10, right? Median. Median is the middle number. So if I list all my numbers in order from biggest to smallest, if I list all my numbers in order from smallest to biggest, right, the one right in the middle is your median. And finally, mode is the number that occurs the most. Mode we don't care about too much. In statistics, the mode doesn't really tell us that much information. Like, yeah, that's cool that that occurs the most, but it doesn't always mean anything to us. So we don't really care about the mode. We really only care about the mean and the median. All right. Then our standard deviation. Our standard deviation is a measurement of how spread out the numbers are. We're going to make that A prettier. So the higher the number, the more spread out they are. The greater the standard deviation, more spread out. So for example, in this class, if I was doing a survey and asked everyone what their age was, right, most of us are the same age. You'd have a very small standard deviation, right? Everyone would be right, like 15, 16, right around there. Versus if I ask something like, how tall are you? Now our heights can range a lot more. So that would have a much bigger standard deviation because we're kind of all over the place for that one. Okay. All right, so let's look at an example. The Chapter 3 and Chapter 4 scores from Mr. Hoff's class are shown below. Find the mean, median, and standard deviation and compare the two sets of data. Okay. So to do this, we are going to use Desmos.com. That means from here on out, you will need to bring your laptop to class so that you can use it for some of these things. So if we pull up our Google, it's not popping up for me to type, that's fine. So Desmos.com, mine pops up right away. Okay. And they have all sorts of calculators too, but we're going to start graphing. Technically, not really graphing, but we're going to use this function. The next thing we're going to do is type L equals and put these brackets. Okay. So the square ones are called brackets instead of parentheses. And inside those brackets, we're going to list these numbers. So, for example, 85, 80, dot, dot, dot. Okay. 75, 75 again, 70. So I'm going through the list that's on my, the Mr. Hoff's second period, chapter 3 scores, and we're just going to quickly type all of these in. This is the thing that's going to take the longest, but I promise you, typing them in is a lot shorter than doing all of these calculations by hand, especially the standard deviation calculation. 80, 75, 75, 70, 80, 70, 3 75s. Do more, 7. Lots of people got 75 on this test. 1 more. So the last thing I like to do is this L equals 23 elements list. This 23 right here tells us how many numbers we typed in. So I just like to double check and count the number of numbers I actually have and make sure I didn't skip any or do some twice. So there are 10 in each of these rows. That's 20, 1, 2, 3, 23. Fabulous. So yes, we did have the correct amount. Great. So our list is in the calculator. So now we want to find our mean, and median and standard deviation. For mean, you literally type in mean of L. Okay. And it will tell us, oh, our mean is 75. That's nice. Sorry, this is supposed to be parentheses, not brackets. Okay. Our median is just as easy if I type in the median of L. It also equals 75. That's nice. Oh, checked. And finally, we have our standard deviation. And just how I abbreviated it, the div of L. Okay, so that one gets abbreviated. You do not have to type in the whole word standard deviation. Okay, so if I make another, and we get about 3.99. All right, looking at our second set of data, I'm going to do the same thing. What's nice about Desmos, though, is I'm just going to take all of these out. It's very confused, and that's fine with our mean, median, and standard deviation here. But I'm just going to go ahead and type in my new data. 100, 100. For sake of time, jumping forward a little bit with all of our data in. We have 95, all right, or we have 23 elements. Again, Sorry guys, it's weird. Our 23 elements, which we do have on our 23 elements in our data, so that works. And then we want to find our mean, median, and standard deviation. What's lucky about this is it's already here, okay? So, our mean of L is 75. Our median is 95. And our standard deviation of L is 36.8. Is that correct? So we can compare these, and really what this is if you look, they have the same mean, so these two classes got the same average, but they're right, this is the same, but this is not the same, right? So if you look, our standard deviation, this set of class data is way more spread out. So while they have the same average, this class, they all got around the same score, and this class, some people did really well, and some people did really bad. Okay, so that's how that standard deviation tells you, is, well, these are way more spread out than these. Okay. All right, let's look at our next set of vocab. We're going to look at normal distributions and skewed distributions. A normal distribution is the data is centered at the mean. Okay, and our normal distribution, we say it has this bell shape, right? Because it looks like a bell. So the most of your values are in the middle, and then as you go out towards the sides, you get less. So like for our test situation, right? Most people should get a 75 on the test if it's normally distributed. And as you go out, like a few people get 100 maybe, and a few people get 50, whatever, right? So for the most part, the majority of people are in that middle. We have positively skewed, right? So it gets pulled to the left, and there's a little tail to the right, and negatively skewed gets pulled to the right and has a little tail to the left. So a skewed distribution is not centered. Okay. All right, so this is important because most of the things we're going to talk about in this class and the calculations we do really only work if your data is what we say approximately normal. Nothing's going to be 100% perfect normal distribution unless you make up the data. But if you can say it's approximately normal, then you can do a lot more calculations with it. Okay? All right, so let's turn the page. Okay. So, it says use the histogram on the right. The mean of the data is 15 and the standard deviation is 2. Is the data approximately normal or skewed? Okay. So if we look at this, right, I can kind of draw that shape. Again, it's not perfect, but we're going to say this is approximately normal. Okay. It is kind of centered around that middle, all right, going down towards the edges. It is approximately normal. Okay. B, what is the smallest number that is 2 standard deviations above the mean? Well, our mean is 15. So we're going to take, what we're going to do is we're going to take our mean, and since it's above, we're going to add 2 times the standard deviation. Okay. So in this case, our mean is 15 plus 2 times, and our standard deviation happens to be 2. Well, 15 plus 2 times 2 is 19. So it's that number. And then C is approximately how many numbers did you get that are more than 1 standard deviation above the mean? Well, that's more than that, so that one doesn't count. So it's only these numbers that count. Well, there's 0 here, and there's 1 here. And 0 plus 1 is 1. Part D, what is the largest number that is 1 standard deviation below the mean? So I'm going to do the same type of thing. Mean minus, it's only 1 times your standard deviation. Well, again, our mean is 15 minus 1 times 2. Well, 1 times 2 is 2, and 15 minus 2 is 13. There's my cutoff point, right? So approximately how many numbers did you get that are more than 1 standard deviation below the mean? So now I'm going just these numbers. There's 1 here, 1 here, 1 here. 1 plus 1 plus 1 is 3 numbers. All right, looking at our next example, right, the mean ACT score is 28 and the standard deviation is 3. Is it normal or skewed? This is definitely skewed. Right, looking like that, right? The centering is over here, it's not in the center. So then, we can still ask these questions. They're not as accurate, but that's okay. What is the highest score that is 2 standard deviations below the mean? So again, mean, it's below, so minus 2 standard deviations. So our mean is 28 minus 2 times 3. Well, 28 minus 6 is 22. Here, we can't answer. Unknown, in this case, was what the table they gave us. So we could say maybe there's 0. Maybe it doesn't go that low. Maybe no one can score lower than a 24. Seems very unlikely. All right. Then what is the lowest score that is 1 standard deviation above the mean? Well, since it's above, that's mean plus 1 times your standard deviation, which is 28 plus 1 times 3. Which gives us 31. This one does have a cutoff right here. Estimate the number of scores that are more than 1 standard deviation above the mean. So if you look, we have above this mean, right, above the 31, we have 2 scores here. Therefore, 2 plus 1 plus 1 plus 2, we're going to have a total of 6 scores, these 6 here, that are above that mean. Okay? All right, that is it. I will, this video watched by Wednesday. Have a good rest of your day.